Okay, so welcome to this video. This video is about pointers when used with arrays. So there's a very strong relationship between pointers and arrays in C++, as we'll see. So we have defined and initialized an array of integers, and I've stored some values in there, 1, 3, 5, 7, and 9. And then on the next line, I am defining a pointer variable p, which is a pointer to an integer, and I'm initializing it equal to the name of the array, arr. And in C, the name of the array is considered equivalent to the address of the first element or address of its first element. So in this case, the name arr will be the address of wherever this one is stored in memory. By the way, you could equivalently do the same thing using this statement saying int star p equals ampersand arr 0. So the address of operator can certainly be used in this case as well. And I'm saying fetch the address of arr 0, which is the first element in the array. So arr and ampersand arr 0 both are identical. You can use either of them. But what I want to demonstrate here is pointer arithmetic. So on this next line, what I'm doing is I am dereferencing this pointer or using indirection to use this pointer to access the array element, the first array element, which is 1. So on this line, when I say star p, what I'm asking the compiler to do is to go to whatever location whose address is stored in the variable p, go there and display its value on the screen. Since p is pointing to this 1, I should see a 1 on the screen followed by an end line. On the next line, I'm displaying star p plus 1. So what do you think think about what you think this statement will display. Would it display uh, the value of the first element in the array plus 1, or would it first add 1 to the address of the first element, arriving at the second element in the array and display it? So would this asterisk operator, in other words, apply to p and then be added? Or would this addition be performed to p before the indirection is applied? And the correct answer is that this indirection will be done first, giving you a 1, and then this plus 1 will be integer arithmetic. So you'll be adding 1 to 1, resulting in the value 2. On the next line, what I'm doing is I'm making it explicit to the compiler that I wanted to do pointer arithmetic first, add 1 to the value of p, which is the pointer variable, and then do the indirection. So what I'm telling the compiler to do is p is pointing to this first element. It has the address of this element. Add 1 to that address. Now we know, or we should know, that every integer in most machines is stored as 4 bytes. So the question that we should ask ourselves is, would this mean that I am asking the compiler to get to the second byte of that integer? Or what I'm asking it to do is to go from this 1 to this 3? And the answer is that it's the latter. When I do pointer arithmetic, when I add 1 to a pointer variable, then the compiler looks carefully at the type of that pointer, the type that it is pointing to. And since integers are 4 bytes, this plus 1 is actually going to be an addition of 4 to the address stored in P. So earlier P was pointing to this number 1, and then P plus 1 would be something that points to or is the address of this number 3. So, and then there's this indirection. So you get the value 3. And then similarly, you can do plus plus, and that should also perform pointer arithmetic the same way as P plus 1 was done. However, since this is a post increment operation, what would happen is that in this cout statement, E will continue to point to 1. So what you see on the screen will be a 1, and only after that the pointer P will start pointing to the number 3. And on the next line, you should see the value 3 on the screen. So let's see this program in action. We'll go ahead and compile this program and then run. So indeed, you see on the first line a 1 being displayed thanks to this cout statement. And then since this is 1, 1 plus 1 would be 2. That's what you see on the second line in this output. The third cout statement gets you this number 3 over here. And then this star p plus plus, like I said earlier, is going to first display the value pointed to by p, which is 1. And then it is going to increment p. So now p will start pointing to number 3 for the next cout statement. And then you see this 3 on the screen. So that is pointers related to arrays and pointer arithmetic. And then similarly, you can do subtraction on pointers, and it would be conceptually done the same way.